Now let's implement the algorithm. We'll keep track of the index of the last unsorted item of the list. Initially, end will refer to the index of the last item in the list, because the entire list is unsorted. We know that we need to make several passes through this algorithm, and in our implementation, we'll do that with a while loop. We stop when end is equal to 0, so we continue as long as it isn't. In each pass, we bubble once through the unsorted section of the list to move the largest item to index end. At that point, the sorted section of the list has grown by 1, so we decrease the index end by 1. Starting at index 0 of the sorted section, we compare the element at index I with the one at index I plus 1. If it's larger than it, we swap the items. Notice that we're using a new notation. The list at index I is assigned the item of the list originally at I plus 1, and the list at I plus 1 is assigned the item originally at index I. Also notice the for loop header. The unsorted part of the list goes from index 0 to index end, but the value of I, the largest value of I, is end minus 1. That's because in the body of the loop, end minus 1 would be compared to the item 1 greater than it, the item at index end. Finally, let's run the doc test. The test case passed, so there's no output in the shell.